Gravity is the most patient force in the universe. It waits for billions of years. It waits for just one moment, when a star runs out of fuel, and the instant the nuclear furnace cools down, gravity wins. It does not happen gently. It is a catastrophe. Imagine the ceiling of your house crashing to the floor at 1/4 the speed of light. The star tries to fight back. It shrinks, but gravity is ruthless. It shatters the structure of atoms. It crushes electrons right into the hearts of nuclei, turning matter into something that defies our everyday experience. What remains is an object that violates every rule of intuition. The star is trapped between existence and total oblivion. It becomes an intermediate hell, a neutron star. But what is the weight of this hell? Step outside. Look at the traffic. SUVs, trucks, buses, tons of steel and iron. Now, in your mind, gather every single vehicle on Earth, all 1.5 billion of them, and crush them. Squeeze them down until that entire mountain of metal fits inside the volume of a single sugar cube. Now, place that cube on a table. Instantly, it will punch through the table, the concrete floor, the foundation, and the crust of the planet. It will fall through the earth like a lead bullet through morning fog, ignoring the rock entirely. This is the reality of a neutron star, a place where standard physics ends and extreme forces begin. Today, we travel to this world. We descend into a gravitational grip where mountains are only a millimeter high, but climbing them is fatal. We will track the rhythm of pulsars, dead hearts beating with the precision of an atomic clock, and we will uncover a source of unimaginable energy, Magnetars, whose fields can sterilize planets from thousands of light years away. The door is open. Let us see what nature can do when the limits are taken off. Imagine we are approaching a neutron star. From a distance of 1,000 miles, it does not look like the stars we are used to. There is no raging fire. There are no flares rising into the sky. Instead, a perfect, hauntingly smooth sphere hangs before us. It glows not with fire, but with a strange, ghostly X-ray radiance that our eyes cannot even fully perceive. The surface of this star is the most perfect ice rink in the universe. Gravity here is a mad sculptor that hates imperfection. It hammers any bulge back into the crust with such force that if we scaled this star up to the size of Earth, the highest mountain on it would be no taller than your knee. But let us go lower. Imagine hovering just a few meters above this surface. Below us lies a crust of crystalline iron, harder than any steel humanity has ever smelted. And on this perfect plane, we see a hill, a tiny bump, only a couple of inches high, no bigger than a matchbox. Your brain tells you, I can step over this, I can step on it. That is a lie. On the surface of a neutron star, that matchbox is a death trap. To climb this 5-millimeter hill, you would need to expend the same amount of energy as a climber scaling Mount Everest in full gear. Down here, gravity does not just pull, it chains you down. Every cell in your body weighs billions of tons. If you drop a standard marshmallow from your own height, it will hit the surface with the energy of the atomic bomb dropped on Hiroshima. The impact would be so violent that the marshmallow's atoms would fuse with the surface atoms in a thermonuclear flash. And all this happens to the accompaniment of a sound that should not exist in a vacuum. The star is spinning. It makes hundreds of revolutions per second. The magnetic field slices through space, creating a hum you would feel not with your ears, but with your bones. It is a low, vibrating rhythm, the sound of an engine the size of a city. This is not a dead body, It is a machine working at the very limit of physics. We are standing on the threshold of a breathtaking discovery. What you just heard is only the facade of the building, the shiny shell. But the most interesting part is hidden inside, beneath this iron crust. In a minute, we will open the door and enter nature's strangest laboratory to take this mechanism apart, screw by screw. Entry to this expedition is open to everyone, but the best payment for our fuel is your subscription. Click the button to take a seat in the front row of our research vessel. We are departing into the depths of matter. Are you ready? Then let us recall how it all began and why scientists for half a century refused to believe that monsters like this could exist at all. For the better part of the 20th century, physicists lived in a very comfortable, ordered world. We had a map of reality, and it seemed complete. We looked at matter and saw strict order. We looked at the stars and saw a predictable life cycle similar to the human one: birth, bright maturity, and a quiet old age. To understand how deep our delusion was, we need to look at the very foundation of this world, the atom. In school, we were taught that an atom is like a tiny solid solar system, a nucleus in the center, electrons in orbit. But this beautiful model hides the primary, frightening secret of matter, its absolute emptiness. Imagine that an atom is a massive cathedral, high vaults, echoing halls, giant space. If the nucleus of the atom is a small fly sitting on the altar in the center of the hall, then the nearest electron is a speck of dust circling near the very top of the dome, a kilometer away from the altar. Everything in between them is nothing. Vacuum. You, me, this screen, the cliffs of the Grand Canyon, and the steel of skyscrapers. We are all 99.9% empty space. We are ghosts pretending to be solid bodies. But this raises a question that kept physicists awake at night. If we consist almost entirely of emptiness, why can I not walk through a wall? Why, when I slam my fist on a table, does my hand not pass through it like mist? The truth is, you never touch anything. When you think you are sitting on a chair, you are actually hovering above it at a height of 1/1000th of a centimeter. The answer lies in personal space. Quantum mechanics gave us a rule that seemed as unshakable as granite. Two particles of matter cannot occupy the same place at the same time. Electrons are antisocial creatures. They furiously defend their territory. When you try to squeeze a stone, the atoms resist. The electrons push away from each other, creating an invisible but insurmountable barrier. This was called the exclusion principle, but let us call it simply the fundamental law of inviolability. It was this law, we thought, that saved stars from total annihilation. Astronomers looked into the sky and saw white dwarfs. These were the corpses of stars similar to our sun. When such a star dies, gravity tries to crush it. It squeezes it down to the size of Earth. But then the law of inviolability took effect. The electrons braced themselves, locked elbows, and told gravity, "Enough, you cannot go further." Matter turned into a giant glowing diamond. A teaspoon of such substance would weigh as much as a truck, but it remained stable. It was a retirement home for stars, a quiet, peaceful eternity. We believed that matter had a breaking point, a concrete wall that could not be breached. We believed that nature would not allow substance to be compressed any tighter than in a white dwarf. It seemed logical. You cannot pack a suitcase infinitely. At some point, the zipper simply stops closing. Scientists were certain. The universe has a built-in fuse. If gravity becomes too strong, matter simply blocks the compression. protecting the very structure of reality. It was a beautiful theory. It gave us a sense of safety. It told us that there are rules in the universe that cannot be broken, even during the worst catastrophe. We had assembled this puzzle. We had the box, we had the sample picture, and every piece fit perfectly into its place. We were sure we knew what the finale of any star looked like. Case closed. We did not know one thing, that there are objects in space that do not care about our fuses. We were standing on thin ice, believing it to be solid ground, and we did not even hear the treacherous cracks forming beneath our feet. The illusion of understanding ended on one specific day, when radio telescopes picked up a signal that, according to our textbooks, simply could not exist. There is an old piece of wisdom in science. The greatest discoveries that turn the world upside down do not start with a triumphant cry of Eureka. They begin with a quiet, puzzled whisper. That is strange. This is exactly what happened in the cold November of 1967 on a muddy field near Cambridge. There were no futuristic laboratories, no sterile white coats, no giant dishes of the kind we see in movies. The instrument destined to change history looked like a farmer's fence. It was hundreds of wooden poles and thousands of meters of copper wire, strung up like a giant web to catch faint radio waves. A graduate student named Jocelyn Bell was the keeper of this web. Her work was grueling. Every single day, she analyzed 30 meters of paper tape, data scratched out by pen recorders listening to the cosmos. Most of the time, the universe sounded like chaos. Static noise, interference from French television, sparks from passing cars, the random breathing of the galaxy. But one night, amidst miles of useless noise, the recorder's pen jerked in an unusual way. It was a tiny jagged mark on the paper, a barely visible blip taking up only half an inch. Bell called it scruff. She could have ignored it. She could have blamed it on a bad wire connection or a thermostat in the next room. But she looked closer. The signal repeated, then again and again, every 1.337 seconds. Tick, tick, tick. The rhythm was frighteningly perfect. It was more precise than the most expensive mechanical watch on Earth. It did not falter by even a fraction of a second. In that moment, the old picture of the world, built by physicists for centuries, began to crack. When this data hit the professors' desks, it did not cause the joy of discovery. It caused a cold sweat, because this signal contradicted common sense and every known law of astrophysics. Stars are not machines. They are giant, lumbering balls of gas. They can change brightness. They can pulse like a heart, but that process takes days, weeks, or months. A star needs time to physically expand and contract. Imagine trying to make an elephant tap dance at the speed of a hummingbird's wing. Inertia simply will not allow it. But the signal was there. It was real. It was as if you dropped a heavy bowling ball from the roof of a skyscraper, expecting it to crash down, but instead, it just hung in the air at the 5th floor. Your brain refuses to believe your eyes. You check gravity. You wipe your glasses. You recount the floors, but the ball continues to hang. Gravity does not work that way. Stars do not work that way. If our sun, or even a dense white dwarf, started spinning at that speed, 1 revolution per second, centrifugal force would tear them apart instantly. Imagine a wet tennis ball stuck on a power drill. As soon as you pull the trigger, the water flies out in all directions. It is the same here. Any normal star would have sprayed itself across the entire solar system. Gravity would simply not be strong enough to hold the matter together on such a mad carousel. For an object to spin that fast and not crumble into dust, it must possess the gravity of a monster. It must be small, no bigger than London, and dense as the nucleus of an atom itself. But we remember the law of inviolability. We knew that matter cannot be that dense. The electrons will not allow it. Scientists were at a dead end. Before them lay a fact. Something in deep space is operating like a beacon, sending pulses with the precision of a metronome. And standing behind them was all of 20th century physics, screaming, "This is impossible. Such an object does not exist." They were left with only three options. Either our instruments were lying, and it was an equipment error. Either the universe found a way to break the law of inviolability and create a monster, or someone built this beacon artificially. The first reaction of the scientific community was predictable: denial. They could not accept that nature was capable of such violence against matter. So they clung to an explanation that, strangely enough, seemed more rational to them than breaking the laws of physics. They decided they had found aliens. There are pages in the history of science that scientists do not like to show the public. These are moments of confusion, moments when the rational mind, faced with the inexplicable, starts seeking salvation in fiction. In 1967, in that same field near Cambridge, Jocelyn Bell took a red pen and wrote 4 letters in the margins of her data printout. LGM1. It was an abbreviation. It stood for Little Green Men. Today, it sounds like a joke, but back then, in the cold silence of the radio observatory, no one was laughing. Anthony Hewish and Jocelyn Bell were terrified. They understood if they published this data, they would either be ridiculed and their careers destroyed, or they would change the history of humanity forever, because the signal was too perfect. Nature is chaos, exploding stars, colliding galaxies, gas clouds. All of this sounds like noise in the radio spectrum, like the crackle of a bonfire or the roar of a waterfall. These are random, disorderly processes, but the signal they caught was different. It was clean, it was rhythmic. Tick, tick, tick. Imagine you are walking through a wild, uninhabited forest. You see broken branches, rocks, leaves, the chaos of nature. And suddenly, on a stump, you find a working metronome. It is ticking. It does not skip a beat. It does not react to the wind. Your first thought will not be, "This metronome grew here by itself." Your first thought will be, "Someone put it here." The scientists began a feverish verification process. It was like trying to navigate a strange city with an old map. You see a street that should not be there, and instead of admitting the map is outdated, you look for a defect in your own vision. First, they decided it was interference, maybe a secret Soviet radar, or a spy satellite, or someone turned on a thermostat in the next building, and it was interfering with the equipment. They checked all flight schedules. They checked every electrical appliance within a mile. They even checked if it could be a signal reflection from the moon. Nothing. The source of the signal moved along with the stars. It was coming from deep space, from a point where there was nothing but emptiness. This led them to a frightening conclusion. If it is not interference and not an equipment error, then it is an object pulsing every 1.3 seconds. And here, physics said a firm no. Remember our example with the elephant and the tap dance. A star is a giant body. For a star to blink to change its brightness, it must physically contract or rotate. A white dwarf, the densest object known at that time, is the size of Earth. If Earth tried to make a full rotation around its axis in 1 second, The centrifugal force at the equator would exceed gravity by millions of times. The planet or star would simply fly apart into pieces like an overripe watermelon shot with a shotgun. In 1967, there was no model that could explain a natural object capable of withstanding such rotation. It was physically impossible. Matter could not be that strong, so that left only one option, an option that was both terrifying and mesmerizing: an artificial beacon. Scientists seriously discussed the possibility that they had intercepted a navigation signal from a Type II civilization on the Kardashev scale. It explained everything. Perfect rhythm? It is a machine. Impossible power? They have technologies we do not understand. Absence of other signals? Perhaps it is just a beacon warning of danger, a cosmic buoy. For several weeks, Hewish's group lived with a secret that burned their hands. They thought they were holding proof of contact. They even discussed whether they had the moral right to burn the data to avoid causing panic in the world. It was as if you found a time bomb in your living room. You do not know who planted it. You do not know when it will explode, but you hear the ticking and you are afraid to call for help. But then something happened that destroyed the alien theory and opened the door to a real nightmare. They found a second signal in another part of the sky, and then a third, and a fourth. The chance that 4 different alien civilizations simultaneously decided to build identical beacons and point them at Earth was 0. Furthermore, analysis showed something strange. The signal was broadband. When we humans want to transmit information, we use a narrow frequency, like a laser beam, to save energy. But these objects were screaming across the entire frequency range at once. They were dumping a monstrous amount of energy into space without any sense or economy. It did not sound like intelligent speech. It sounded like a scream of pain. And then the realization came. These are not little green men. Aliens would have been a miracle. But the reality turned out to be scarier. We did not find neighbors. We found a new type of matter. The scientists had to admit defeat. The old map was wrong. There existed an object in the universe that spun at the speed of a kitchen blender, weighed as much as the sun, and was compressed to the size of Manhattan. They had to admit the existence of the neutron star. But to understand how this monster works and why it does not crumble into dust, we need to look inside. We need to understand what happens to matter when it is squeezed tighter than quantum mechanics allows. When the hypothesis of little green men died, astrophysicists were left alone with a reality that was far more terrifying than any science fiction. They had to admit that nature created an object that violates the rules of the road of the universe. To understand why scientists were in such horror, we need to return to basic mechanics. We need to understand how a star can spin at such insane speed. Imagine a figure skater on Olympic ice. She starts rotating with her arms wide open. She moves slowly, gracefully, but then she makes one simple move. She presses her arms to her chest, and in that second, her speed skyrockets. She turns into a blurred spot. This is the law of conservation of angular momentum. If you decrease your size, you are obligated to increase your speed to preserve the energy of rotation. Now, replace the figure skater with a star 1,000,000 miles wide. This star spun slowly, lazily in space for millions of years. But when the fuel ran out, a collapse occurred. In a fraction of a second, this giant ball shrank to the size of a city. 1,000,000 miles turned into 12. The arms-in effect works here on a cosmic scale. The rotation speed does not increase twice, and not 10 times. it increases millions of times. This is where that rhythm comes from. It is the death pirouette of a dying star, accelerated to the limits of physics. But here a problem arises that should have killed this theory at the root. Imagine you are sitting on a playground merry-go-round. Someone starts spinning it. First it is fun, then it is scary. Then centrifugal force becomes so powerful that your hands fail and you are thrown outward. If you spin the carousel hard enough, it will fall apart itself. Bolts will fly out, metal will snap. No material, not steel, not titanium, not diamond, can withstand rotation at 700 revolutions per second. The surface of such a star moves at a speed close to a quarter of the speed of light. Centrifugal force at the pulsar's equator is so monstrous that it should have torn the star into dust instantly. It should have sprayed its matter across the galaxy like dough flying off a mixer. Why is it intact? What holds it together? The answer is gravity, but not the cozy gravity that holds us on Earth. This is monster gravity. In this battle of titans, centrifugal force wanting to tear the star apart, and gravity wanting to crush it, compression wins. Gravity acts here like an invisible steel fist, holding the spinning city in a vice. But for this fist to be that strong, matter itself must change. We have reached the grimmest moment of our investigation. At the beginning, we said that atoms are empty space, that electrons protect their personal space. Well, inside a neutron star, that protection is broken. The pressure during the collapse was so strong that the law of inviolability was repealed. Gravity took the electrons and forcefully drove them right into the protons. Imagine that you take two magnets that repel each other and squeeze them with a press until they merge into a single piece of metal. Minus killed plus. The charge disappeared. Only neutrons remained. The emptiness vanished. The entire star turned into one giant atomic nucleus, the size of Manhattan. This is no longer ordinary matter. You will not find this in the periodic table. Scientists call it degenerate gas, but astrophysicists have a stranger, almost culinary name for what happens in the bowels of this monster. They call it nuclear pasta. This is not a joke. When you descend beneath the crust of a neutron star, the pressure becomes so absurd that neutrons begin to arrange themselves into strange structures. First, they gather into balls, the Naughty phase. Then deeper down, pressure rolls them into long tubes, the spaghetti phase. Even deeper, they flatten into sheets, the lasagna phase. Sounds harmless, right? But do not let the names fool you. This pasta is the strongest material in the universe. It is 10 billion times stronger than steel. It is impossible to break. It is impossible to bend. If you wanted to break off a piece of this spaghetti, you would need the energy of all Earth's nuclear arsenals detonated simultaneously, and you would most likely not even leave a scratch. It is from this super dense, super strong matter that our top is built. It is the perfect mechanism, an absolutely solid body rotating in a vacuum. No friction, no air resistance, no wear of parts. That is why their rhythm is so perfect. Tick, tick. It is not a clock that someone wound up. It is the inertia of a dead god, encased in armor of nuclear pasta. But even this perfection has a flaw. Sometimes, very rarely, the rhythm falters. The star shudders. In the world of ordinary matter, we call it an earthquake. There, it is called a starquake. And when the crust of nuclear pasta cracks by even a millimeter, energy is released that is capable of burning out life, light years away. But we will talk about that, about the magnetic wrath of this star in the next chapter. Right now, we must realize one thing. The model is saved, but the price of this salvation is our peace of mind. We proved it is not aliens, but we proved that the universe is capable of creating zombie stars that violate every rule of intuition and consist of matter that our brains can barely imagine. Up until now, we have spoken of stars as clocks. Pulsars are metronomes. They are predictable. They are stable. You can set your time by them, and they will never let you down. We soothed ourselves with the thought that neutron stars are, of course, extreme objects, but they are tamed by the laws of physics. They sit in their gravitational cages and simply spin. But on March 5th, 1979, the universe reminded us that it does not like it when we feel safe. It was the height of the Cold War. The world lived in tension. Nerves among the military were at the limit. An armada of Vela spy satellites circled in space. Their task was simple and terrifying: to look not at the stars, but at the Earth. They were looking for characteristic gamma-ray flashes, the signature of secret nuclear tests. These satellites were paranoid. They were waiting for the end of the world. And on that day, March 5th, they saw it. At 10:51 a.m. Eastern Time, sensors on 9 different satellites scattered across the solar system from Earth's orbit to Venus went off the scale simultaneously. This was not just a signal, it was a sledgehammer blow to the sensors. The gamma-ray flash was so powerful that the protection systems on the satellites failed. Instruments built to register nuclear explosions simply went blind. Graphs turned into a straight line shooting into the ceiling. For several milliseconds, the satellites were useless. They were like a person in a dark room who was shot in the face with a camera flash at point-blank range. Panic began in the command centers. The first thought was obvious. Someone pressed the red button. Someone detonated a bomb. And judging by the signal strength, it was not just a bomb, but an entire arsenal. But when the military and scientists began triangulating the signal, their fear was replaced by total bewilderment. The signal did not come from the Soviet Union. It did not come from Earth, and not even from the Sun. It came from the void. The vector pointed to the Large Magellanic Cloud, a satellite galaxy hanging in the neighborhood of our Milky Way. This changed everything. Imagine you see a flash of light that momentarily blinds you, forcing you to squint. You think someone turned on a spotlight a meter from your face, but then you are told that this spotlight was not a meter away, but in Paris, and you are in New York. For the light to be that bright from such a distance, the source must possess the brightness of 1,000,000 suns. When astrophysicists calculated the energy of the March 5th flash, the calculators output numbers that seemed like an error, and in 0.2 of a second, a single snap of fingers, this unknown object ejected as much energy into space as our sun produces in 1,000 years. 1,000 years of heat and light compressed into one instantaneous, furious scream. This destroyed our beautiful theory about stable pulsars. Pulsars do not do this. A spinning top cannot explode. It has no energy source for such a discharge. It is already dead. It has already spent all its fuel. It was as if you found an old rusted car frame in a junkyard without an engine or gasoline, and suddenly it tore off, breaking the sound barrier. Where is the energy coming from? Where was it hiding it? Scientists called it a gamma-ray burst, but that name explained nothing. It was just a label for our ignorance. We looked into the void, expecting to see silence or the measured ticking of a clock, but the void shot at us. They realized they were dealing with a new class of objects. This is not just a dead star, it is a zombie star that somehow preserved a colossal reserve of malice. We found the crime scene. It was the N49 nebula in the Large Magellanic Cloud, remnants of a supernova. There, in the center of a cloud of glowing gas, sat the culprit. At first glance, it looked like an ordinary neutron star, the same size, about 12 miles across, the same mass, but it behaved like a terrorist. This discovery forced us to reconsider everything we knew about the death of stars. We thought gravity was the only monster in this story. We thought the collapse ends with the formation of a dense ball, and that is it. But we forgot about one more force, a force we are used to seeing every day when we stick a note on the refrigerator: magnetism. It turned out that when a star dies, it can leave behind not only a gravitational well, but a magnetic field of such intensity that it becomes a material object. We found not just a pulsar, we found a magnetar. And if a pulsar is a clock, then a magnetar is a loaded shotgun pressed against the temple of the galaxy. To understand why this object is so dangerous, we need to try to imagine the strength of its field. And I warn you right now, the human brain is not equipped for such numbers. When we think of magnets, we usually picture fairly harmless things: souvenirs holding a grocery list on the refrigerator door, a compass needle lazily turning north. In our everyday world, magnetism is a weak, almost ghostly force. Gravity pins us to the ground, electricity lights our cities, but magnetism, it just exists somewhere in the background, unnoticed and silent. Even the most powerful machines created by human genius barely scratch the surface of this force's true potential. Take an MRI machine in a modern hospital. When you lie down in that sterile white tunnel, doctors strictly insist you remove all metal objects: rings, watches, piercings, belt buckles. Why? Because the magnetic field inside the tunnel is so strong that it can rip a ballpoint pen out of your pocket and turn it into a flying bullet. The strength of this field is about 30,000 Gauss. That is 60,000 times stronger than Earth's natural magnetic field. For us, this is the limit of technology, a dangerous but controlled force. But the object that triggered the March 5th gamma-ray burst laughs at our machines. A magnetar possesses a magnetic field of 1 quadrillion Gauss. That is a 1 followed by 15 zeros. The human brain is not evolutionarily adapted to work with such numbers. For us, a million, a billion, and a quadrillion are all just a lot. We do not feel the difference on an intuitive level. So to truly understand the scale of the threat, we need to conduct another thought experiment. We need to take this magnetar from the depths of space and mentally drag it closer to our home. Imagine that this object, a compressed city only 12 miles in diameter, slowly floats into our solar system. It does not approach Earth closely. It stops halfway to the moon. This is a huge distance, about 120,000 miles away from us. Gravity at such a distance would cause monstrous tides, tsunamis, perhaps earthquakes, but it would not kill us instantly. We would survive. But magnetism works differently. The moment the magnetar takes position halfway to the moon, invisible chaos begins on Earth. Your credit card, sitting in the wallet in your back pocket, is instantly demagnetized. The magnetic strip is wiped clean. But those are trifles. Hard drives and Google servers, bank accounts, military launch codes, archives of all human history. Everything turns into digital garbage in a fraction of a second. The entire electronic memory of civilization is erased faster than you can blink. The internet physically ceases to exist. But that is only the beginning, because we are continuing our experiment. The Magnetar keeps getting closer. Let us say it flies to a distance of 600 miles, 1,000 kilometers. Here begins true physical horror. At this boundary, the magnetic field becomes so aggressive that it starts interacting with your body on a biological level. There is iron in our blood. It is part of the hemoglobin that carries oxygen to your organs. Usually, iron atoms are securely locked inside complex protein cells. They are non-magnetic in the usual sense, but a magnetar field of this strength does not recognize chemical bonds. It begins to pull every iron atom in your blood, and it pulls them with the force of an accelerating locomotive. This is not a metaphor from a cheap comic book. This is harsh biophysics. You would literally start being torn apart from the inside because your own blood, obeying the magnetic call, would try to break out through veins, through skin, striving toward the star. But even this will not kill you. First, death will come sooner, and it will be far stranger and quieter. To understand its mechanism, you need to remember what an atom looks like in a textbook. It is a sphere, a round cloud of electrons orbiting a nucleus. All of chemistry is a game of Lego, where the pieces must fit perfectly together. Atoms connect into molecules, molecules into cells, cells into you. This giant complex construction holds together only because atoms retain their round shape. The key fits the lock. In a magnetar's field, the concept of a sphere ceases to exist. Magnetic pressure on electron orbits becomes stronger than the electrical forces holding the atom together. The field crushes the electron clouds. Atoms stretch out. They turn from spheres into thin, long needles. Their length becomes hundreds of times their width. Imagine you built a magnificent complex castle out of Lego bricks, and now imagine that every single brick in the foundation of this castle suddenly melted and turned into a long, thin spoke. What happens to the castle? It instantly crumbles, bonds break, chemistry stops working. DNA falls apart into useless fragments. Proteins lose their structure and function. At a distance of 600 miles from a magnetar, your body simply ceases to be a biological object. You do not die from pain or trauma. You disappear as an ordered structure. You turn into a cloud of atomic dust consisting of needle-shaped atoms drifting in the magnetic wind. And it happens instantly, quietly, without a single shot. Where does such unimaginable power come from? How does nature create such a monster at all? The answer lies in the star's memory. When a giant star dies and shrinks, the same thing happens to it as to our figure skater, only instead of speed, it conserves magnetism. Magnetic lines pierce the star like thousands of invisible threads. When the star collapses, these threads do not disappear. They are compressed along with it. Imagine you have a bundle of 1,000,000 wool threads scattered across a huge room, and now you grab them all and squeeze them into one small fist. The density of threads in your fist will be off the charts. A magnetar is a fossil magnetic field. It is the energy of a giant star trapped in a tiny ball 12 miles wide. This field is so dense that the vacuum itself around the star begins to behave strangely. The void becomes viscous. Light passing by refracts as if passing through a thick liquid or prism. This is called vacuum birefringence. Space itself polarizes, lining up in formation before this force. We thought we understood the cosmos. We thought it was empty, cold, and indifferent. But this stubborn signal, this impossible energy proven us wrong. Space is not empty. It is filled with invisible minefields, and sometimes these mines detonate. We have reached the line where old physics ends. We found the object. We understood how it kills at close range. But we have not yet answered the main question. What happens when this compressed magnetic spring finally cannot hold and snaps? What happens when the crust of nuclear pasta cracks, releasing the energy of thousands of suns? The answer to this question might explain why we still do not hear the voices of other civilizations. Perhaps our galaxy is not a quiet harbor, but a battlefield where a weapon of sterilization periodically goes off, from which there is no hiding. For a long time, we looked at gamma-ray bursts, the way primitive humans looked at lightning. We saw the blinding light. We heard the celestial rumble, but we completely failed to understand the mechanism. We wrote it off as random glitches, as space weather, as instrument errors. But the more data we gathered, the more terrifying the picture became. We realized that all this time, we were not looking at the object itself, but only at its shadow cast upon the wall of a cosmic cave. To see the true face of this monster, we need to look under the hood. We need to understand what happens to that nuclear pasta, the strongest material in the universe, when it enters a mortal struggle with a magnetic field. To begin, let us return to our metaphor. Imagine you are holding a thick, strong rubber band. You grab it by both ends and start twisting, turn after turn. At first, the band yields easily, then it begins to resist. Mechanical tension builds up in the rubber. Your knuckles turn white from the strain. If you continue to twist, ignoring the resistance, an inevitable moment will arrive. The rubber can no longer stretch, it will snap, and if that rubber band was powerful, the blow to your fingers will not just be painful, it will slice the skin to the bone. A neutron star does the same thing, but on a scale that chills the blood and fails the imagination. Remember, a magnetar is a spinning ball, 12 miles in diameter. Its crust is a solid crystalline armor of nuclear pasta, 10 billion times stronger than steel. It is the perfect prison cell, and its magnetic field is the invisible beast inside this cell. Magnetic field lines do not just surround the star, they pierce through it. They are embedded in this crust like rebar in concrete. Because the star spins and spins insanely fast, these magnetic lines begin to tangle. The inner layers of the star may rotate slightly faster than the crust. The field begins to twist. It pushes on the crust from the inside. It tries to shift it, tear it, rearrange it to suit itself. It pushes with a force that is impossible to describe in earthly terms. This is a pressure of trillions of tons per square inch. It is a war of two absolutes, the infinite strength of the crust and the infinite power of the magnetic field. And at some point, the crust loses, a starquake occurs. The word itself sounds almost harmless. On Earth, an earthquake is when tectonic plates shift a few feet, destroying cities. On a magnetar, the scale of movement seems laughable. The crust cracks and shifts only by the thickness of a human hair, or even less, the width of a single atom. It seems like nothing, a microscopic shiver, but do not forget where we are. We are in a world of ultimate density. Here, in this gravitational hell, a crust shift the size of a fingernail releases more energy than 1,000,000 hydrogen bombs. The moment the crust cracks, the rubber band snap occurs. The tangled magnetic field, held back for centuries, instantly straightens out. This is what physicists call magnetic reconnection. All the accumulated energy is ejected outward in 1 millisecond. This is not just an explosion, it is the sterilization of space. In that brief instant, the star becomes brighter than our entire Milky Way galaxy, which consists of 100 billion stars. One tiny ball eclipses the collective light of billions of suns. It is a spotlight of death that turns on for a fraction of a second, but its light is visible across the entire universe. Many of you are thinking right now, okay, that is impressive, but it happens somewhere out there, far away, in the world of abstract physics. It has nothing to do with me. You are wrong. The universe has already touched us with the finger of this monster. Let us transport ourselves to the recent past, December 27th, 2004. The world had just celebrated Christmas. People were finishing holiday dinners, opening gifts. Space was quiet, but suddenly, without any warning, an invisible wave struck the Earth. It did not kill people, but it physically slapped the planet. The upper layers of Earth's atmosphere, the ionosphere, suddenly ionized. The night side of the planet glowed momentarily with a ghostly light. Communication satellites registered a monstrous overload. Their sensors, designed for powerful flares from our sun, simply maxed out and shut down. Magnetometers around the world, instruments that monitor Earth's magnetic field, twitched simultaneously. Compass needles wavered. Our planet's magnetic field was compressed by a blow from the outside. Scientists were in shock. They began looking for the source of this attack. They found it. It was a Magnetar with the dry code name SGR 1806-20. And here, when astrophysicists looked at the star chart, true, cold horror gripped them. This object was on the other side of our galaxy. It was in the constellation Sagittarius. The distance to it was 50,000 light years. Think about that number, 50,000 light years. That is an abyss. The light from this flash was flying toward us when our ancestors were still living in caves and hunting mammoths. The entire history of human civilization, the pyramids, Rome, spaceflight, the internet, all of it fit into that span of time while this death ray flew through the void. From such a monstrous distance, the flash should have been invisible. We should not have noticed it, but it was so powerful that it physically hit the Earth. Imagine that someone sneezed in Los Angeles and it shattered windows in New York. That is the scale of energy we are talking about. In 1/10 of a second, this Magnetar ejected as much energy as our sun produces in 150,000 years. After this event, astronomers sat down at their desks and began to calculate. They asked one simple question: what if it were closer? What if this SGR source was not on the other end of the galaxy, but somewhere nearby, say, within 10 light years? By cosmic standards, 10 light years is our backyard. It is the distance to our nearest neighbors. The results of the calculations looked like an apocalypse scenario from which there is no escape. If a flash of such power occurred 10 light years from Earth, human history would end instantly. Gamma radiation of such intensity would destroy the planet's ozone layer in seconds. Our shield, which has protected life from ultraviolet light for billions of years, would simply evaporate. After that, the agony would begin. Solar radiation would begin to burn the surface without hindrance. Phytoplankton in the oceans would die first. This would destroy the food chain from the very bottom. Fish, animals, crops, everything would begin to die. All electronics on the planet would fail forever. Planes would fall from the sky, power grids would melt, data would vanish. We would be thrown back into the Stone Age, but a poisoned, radioactive Stone Age. And the scariest part is, we would not even have time to understand what happened. The light of the flash and the radiation travel at the same speed. We would simply see a bright light, and that would be the last thing we saw. This discovery forced us to fundamentally change our metaphor of the universe. We used to imagine space as a flat, safe sheet of paper, a map where events happen somewhere far away and do not touch us, like a war on the TV news. But Magnetars showed us that the universe is three-dimensional, cramped, and filled with crossfire. Forces pass through our world that we do not control, and against which we cannot defend. We realized that a gamma-ray burst is not just light, it is a bullet, and this bullet flew across the entire galaxy for 50,000 years, only to graze us on the shoulder in 2004. We survived only because of the distance. We were lucky the shooter was standing far away, but next time, the shooter might be closer. This understanding overturned everything. We realized that our peace is an illusion, but this led us to an even deeper question. If the universe is capable of producing such bullets, and if it does so regularly, then maybe that is exactly why we are not alone here. Maybe we live in a labyrinth where a trap lies around every corner. To answer this, we need to understand how rare these monsters are. Is a magnetar a mistake of nature? Yes or no? A rare freak in the family of stars, isn't it? Or is it the standard model, after all? Now that we know what these objects are capable of, we have one last hope left. Hope for statistics. We want to believe that a magnetar is a mistake, a rare mutation, an ugly scar on the face of the galaxy that occurs once in a million. We want to believe that the universe is mostly safe, and such monsters are the exception to the rule. Unfortunately, math is not on our side. Let us look at the facts. Stars die constantly. It is a conveyor belt that has not stopped for a single second since the Big Bang. In our galaxy, the Milky Way, there are between 100 and 400 billion stars. Many of them are massive giants doomed to turn into neutron stars. Astronomers have calculated the number of these dead cities in our galaxy. The figure they arrived at forces us to rethink the very concept of safety. In the Milky Way, there are about 100 million neutron stars drifting. 100 million. Try to comprehend that number. If every neutron star were a sea mine floating in the ocean, you could not swim a mile without hitting one. The galaxy is not an empty room. It is an overcrowded warehouse of explosives. Of course, not all of them are active magnetars. A magnetar is the youth of a neutron star. This phase lasts briefly, only about 10,000 years. After that, the magnetic field weakens, the star calms down, turns into an ordinary radio pulsar, and then simply cools. But this does not make the situation easier. It makes it scarier, because it means that most of these objects are invisible. An active magnetar glows. It screams in the X-ray spectrum. We see it. We can map it and fly around it. But an old, cooled neutron star is a ghost. It is a ball 12 miles in diameter that emits no light. It is absolutely black, and it weighs more than the sun. And the creepiest part is, they do not stay put. When a supernova explosion occurs, it is rarely perfectly symmetrical. Often the explosion gives the star a kick. This kick sends the neutron star flying through the galaxy. Some of them move at a speed of 600 miles per second. That is hundreds of times faster than a bullet. Such an object can cross the distance from Earth to the Moon in 3 minutes. Right now, as you listen to these words, millions of these invisible, super heavy bullets are flying through the darkness of space. They fly between star systems, they cross spiral arms, These are wandering minds. We will not see such a star until it is on our doorstep. If such a dead star flies into the solar system, we do not even need it to be a magnetar. Its gravity alone would be enough to throw Earth out of orbit into the icy void of space, or fling us into the sun. This changes our perception of reality. We are used to thinking of the solar system as a house with strong walls. But there are no walls. We live on an open plain in the middle of a crossfire that has lasted billions of years. The fact that we have existed for 4 billion years and have never collided with such an object is not a guarantee of safety. It is incredible, statistically impossible luck. And here we come to one of the most disturbing questions of modern science, the Fermi Paradox. We look at the sky and ask, where is everybody? Why is space silent? Why do we not hear the radio communications of other civilizations? Why has no one colonized the galaxy? We have come up with many complex explanations. Maybe they are hiding, maybe we are in a zoo, but the existence of Magnetars offers a simpler and more brutal answer. Perhaps the universe is simply too dangerous for long life. Imagine a civilization that arose on a planet located slightly closer to the center of the galaxy, where the density of stars is higher. They developed. They built cities. They invented radio. They were preparing to go to the stars. And then, in a neighboring system, just 5 light years away, an old Magnetar experienced a starquake. One snap of the cosmic rubber band, one flash of gamma radiation, and the civilization is gone. Only ruins remain, slowly destroyed by radiation. The planet is sterilized. Evolution has to start all over again from bacteria. What if life in the universe arises constantly, like grass in the spring? But cosmic weather, these violent flashes, these magnetic storms, regularly mows this grass, preventing it from growing into a forest? Maybe we are alone, not because we are unique, but because we are the only ones who manage to hide in a quiet, boring outskirts of the galaxy, in the interval between shots. We live in the Goldilocks zone, not only in space, but also in time. We arose in a rare moment of calm. It is a frightening thought. It tells us that the universe was not created for us. It is not hostile. It is indifferent. A magnetar does not want to kill us. It simply follows the laws of physics. It is just releasing crustal tension. It does not care if there is a planet nearby, with poets, engineers, and children, or if it is just a chunk of rock. To the universe, we and the rock are the same thing, just a collection of atoms. But it is precisely in this icy indifference, in this mechanical cruelty, that a strange beauty lies. Look at it from the other side. The universe created a mechanism of such power that we can barely comprehend it. It took matter, compressed it to the limit, spun it in a vortex, endowed it with a magnetic field capable of stopping time, and launched it into an infinite dance. This is not a design flaw. It is the pinnacle of nature's engineering. A neutron star is the place where matter shows its limit. Beyond that is only the black hole, only non-existence, and a magnetar is a lighthouse standing at the edge of this abyss. We humans are the only creatures, as far as we know, capable of looking at this lighthouse and understanding what it is. We are the only ones who can see in this death machine, not the wrath of gods, but a physical process. We are sitting on a powder keg. Yes, but we have learned to read the label on that keg, and that makes us special. Most of the audience has already tuned out. The moment we began to speak of quantum mechanics and the extinction of civilizations, they switched to kittens, to the news, to something simple and safe. Evolution has trained the human brain to flee from complexity, but you are still here. You did not flinch at the abyss. You stayed for the substance. This means you belong to a rare breed. People who value truth over comfort. People whose curiosity is stronger than their fear. We build this channel for you. Do not remain a passive observer. Subscribe. Send a signal to the algorithms. Enough of the noise. I want intelligence. And now, Chapter 7. We have spoken at length about death. It is time to speak of life, because these monsters hold a secret without which you and I might simply not exist. At the start of this journey, we looked through telescopes with a sense of superiority. We were explorers, studying strange beasts in a zoo. We felt protected by the thick glass of distance and time. But the story of Magnetars shatters that glass. The shards fall at our feet, and we are left alone with a frightening truth. We are used to thinking of Earth as a fortress, as a specially created home where conditions are perfectly tailored to our needs. But if you look at our planet through the prism of gamma radiation, this home no longer looks cozy. It looks like a target. Let us be honest with ourselves. What is human civilization? If we strip away our pride, our skyscrapers, our symphonies, and our religions, what remains at the bottom line? We are a thin biological film. We are mold growing on a wet rock, hurtling through the void at 67,000 miles per hour. We are not protected by armor. We are protected by a razor-thin layer of gas, our atmosphere. If you shrank Earth to the size of a school globe, this layer would be thinner than a coat of varnish on a wooden stand. That is all that stands between us and the nuclear fire of space. 20 miles of air. We hang in a vacuum, holding on to this rock, hoping that cosmic weather will be kind to us. The discovery of Magnetars changes the very understanding of our place in the universe. Before, we asked, why is the universe so well tuned for life? Now we must ask, why are we still alive? Imagine a soldier running across a battlefield. Bullets whistle around him, shells explode, his comrades fall, but he runs. A minute, 10 minutes, an hour, he has not been wounded once. By the end of the hour, that soldier might start thinking he is special, that he is chosen, that he has a great mission, and bullets cannot touch him. This is human psychology. We seek meaning in our survival, but Magnetars are the cold voice of physics saying, no, you just got lucky. You are not special. You were just running between the trajectories of bullets. In 2004, when the flare from SGR 180620 hit the Earth, the bullet flew a centimeter from our temple. We were not saved by our technology, our wisdom, or our morality. We were saved by distance. We were saved by 50,000 light years of emptiness. If we were in a different place in the galaxy, we would already be gone. If our solar system had passed through a spiral arm 1,000,000 years earlier or later, we would be gone. We live on a cosmic shooting range. The shooters are dying stars. Their weapons are magnetic fields capable of sterilizing planets tens of light years away. And they do not aim, they shoot in all directions, spinning like mad turrets. This realization hits our ego harder than Copernicus, who said Earth is not the center of the world. Copernicus simply moved us to the side. Magnetars tell us that we are an accident, that our history, thousands of years long, is just a short pause between two shots. We emerged during a lull. We took advantage of a temporary truce that did not belong to us to build our cities and invent our gods. But the truce cannot last forever. Statistics are relentless. There are hundreds of millions of neutron stars in our galaxy. They move. We move. Sooner or later, the trajectories will cross. It is not a question of if, it is a question of when. This makes us incredibly fragile, but at the same time, it makes every moment of our existence incredibly valuable, because we understand life is not the norm in the universe. Life is an anomaly. It is a rounding error in the equation of death. The universe tends toward chaos, toward decay, toward radiation, and we are small islands of order resisting this flow. We look at the sky and see not just stars. We see the barrels of loaded guns, and this brings us to the darkest, most disturbing thought of the evening. We love to ask, where is everybody? We look for signals. We build SETI antennas. We send messages on golden records. We shout into the darkness, "Hey, is anyone else here?" And in response, silence. We always thought silence was a riddle, that civilizations are just far away, or hiding, or not born yet. But what if silence is not a riddle? What if silence is the only possible outcome? What if we are looking at the galaxy not as an empty house ready for occupancy, but as an ancient graveyard where most graves do not even have names? What if the great filter talked about by futurists is not war, not a virus, and not artificial intelligence? What if the filter is simply magnetism? Let us face the truth. Perhaps we are alone, not because we are the first, but because we are the survivors. There is a question that has kept humanity awake for 70 years. If the universe is infinite, if there are billions of planets similar to Earth, and if life needs only water and time, and then where is everyone? Why, when we point our radio telescopes at the sky, do we hear only the hiss of hydrogen? Where are the signals? Where are the megastructures? Where are the ships? We named this the Fermi Paradox. We invented dozens of excuses for our imaginary neighbors. We said, they just do not want to talk to us, or they moved into a digital reality, or they are too far away. We comforted ourselves with the hope that the galaxy is a vast, dark forest, full of life that is simply hiding. But the existence of Magnetars forces us to consider another, far more chilling version. What if the forest is not hiding? What if the forest has burned down? Let us look at the history of our own planet. Geologists tell us that life on Earth almost died 5 times. 5 great extinctions. The most mysterious of them happened 440 million years ago. The Ordovician extinction. At that time, life thrived in the oceans, trilobites, mollusks, the first corals, and suddenly, in a single moment on the geological clock, 60% of all living things vanished. No trace of an asteroid, no volcanoes, just death coming from the sky. Scientists studying this period found a strange pattern. Those who lived near the water's surface died out. Those who lived in the deep survived. This is the signature of a killer we know. It looks like the destruction of the ozone layer, an instant strike of ultraviolet radiation. Today, the leading hypothesis states Earth was hit by the beam of a gamma-ray burst. Somewhere within a radius of 6,000 light-years, a star exploded, or the crust of a magnetar cracked. The beam was a glancing blow. It did not burn us completely, it simply disinfected the surface. It was a warning. We survived only because we were primitive. We were mollusks hiding under the weight of the water. If we had possessed cities, power grids, and satellites back then, civilization would have ended forever. And now, scale this up to the entire galaxy. Astronomers have introduced the concept of the galactic habitable zone. We live on the outskirts of the Milky Way, in a bedroom community. Here, stars are few, and they are located far from each other. It is quiet and boring here. That is exactly why we are alive. But look at the center of the galaxy. There, the density of stars is thousands of times higher. It is a metropolis. It is beautiful. The nights there shine with millions of suns. It would seem that is exactly where great civilizations should arise. There is more energy, more planets, less distance between systems. But density comes with a price. More stars means more star deaths. More supernovae, more neutron stars, more magnetars. The center of the galaxy is a radioactive hell. There, starquakes happen constantly. Gamma-ray bursts sweep through space like searchlight beams in a prison yard. There is no room for evolution there. As soon as life is born on a planet, as soon as it tries to crawl out of the ocean onto land, a flash occurs. A magnetic cleaner wipes everything away and presses the reset button. Perhaps we do not hear aliens, not because they are hiding, but because they were erased. Perhaps intelligent life is mold trying to grow in a sterile laboratory where a UV sterilization lamp is turned on regularly. You and I are a lucky colony of bacteria that crawled into a far dark corner under the baseboard, the edge of the galaxy, where the light of the lamp simply does not reach. This changes our view of telescopes. We thought we were looking into a void awaiting guests, but perhaps we are looking at a giant graveyard. Every neutron star is a tombstone for a failed civilization. Every gamma-ray burst we register with satellites, and they happen almost every day, is a report that somewhere in space, another sterilization has been conducted. This is a terrifying picture. It deprives us of the hope of meeting brothers in reason. But in this darkness, there is also a strange, twisted optimism. If this is true, then we are the keepers of the fire. If the center of the galaxy is dead and the outskirts are too sparse, then we are in the only place and at the only time when a mind could become aware of itself. We are not just a biological species. We are the survivors of the cosmic lottery. We passed through a bottleneck that millions of other worlds did not pass through. Our loneliness is not a curse, it is a responsibility. The magnetic monsters cleared the stage, leaving us alone in the spotlight. But the story of Magnetars would be incomplete if we ended it only with death. The universe has a sense of irony. The very same process that kills civilizations makes them possible. The very same explosion that sterilizes planets gifts them with the most desired resource in human history. Look at the ring on your finger. Look at the gold contacts in your phone on which you are watching this video. Do you think this gold was born on Earth? No, Earth does not know how to make gold. The sun does not know how to make gold. Medieval alchemists sought the philosopher's stone, but they were looking in the wrong place. The real treasure factory is located in the hell we just described. To understand how death turns into wealth, we need to see the final act of a neutron star's life. We need to see what happens when two of these monsters collide with each other. Look at your hand. If you have a wedding ring on your finger, or if there are microchips in your phone, you are wearing a piece of the corpse of the monster we have been talking about for the last hour. For all of human history, alchemists tried to turn lead into gold. They sought the philosopher's stone in flasks and furnaces. They did not understand one thing. Earth does not know how to create gold. Our entire planet, with all its volcanoes and pressures, is too cold and weak for this process. Even our sun, a giant thermonuclear reactor, is not capable of creating a single ounce of gold. The sun knows how to make helium. At the end of its life, it will be able to create carbon, maybe a little oxygen, but that is all. The physics of stars is cruel. When a star creates iron, it dies. Iron is the ash of nuclear fusion. It is a wall. To create something heavier than iron gold, platinum, uranium energy is needed that an ordinary star does not possess. Where then did the gold in your ring come from? The answer lies in an event scientists call a kilonova. This is the moment when two of our monsters meet. Imagine a binary system, two neutron stars, two cities the size of Manhattan, circling each other. They have been dancing this deadly waltz for billions of years. But this dance is not eternal. They emit gravitational waves, ripples in the very fabric of space. With every wave, they lose energy. They draw closer, centimeter by centimeter, mile by mile. The death spiral tightens. In the final milliseconds before collision, they spin around each other hundreds of times per second. Gravity strips the crust off them, and then the impact happens. This is not just a crash. It is the most violent event in the universe since the Big Bang. When these two superdense objects smash into each other, matter does not just explode, it splashes. Trillions of tons of nuclear pasta, those same free neutrons compressed to the limit, are ejected into space. And right here, in this expanding cloud of debris, magic happens. Neutrons, freed from monstrous gravity, begin to panic. They look for a partner. They crash into atoms of iron and other light elements. This process is called the R process, rapid neutron capture. It happens in fractions of a second. Atoms are bombarded by neutrons so fast that they do not have time to decay. They get heavier, 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 until they turn into stable heavy metals. In one such explosion, an amount of pure gold exceeding the mass of Jupiter is created. Imagine a planet made entirely of molten gold and platinum flying apart in all directions at the speed of light. It is a cosmic forge. Your ring is not just an ornament. It is shrapnel. It is a fragment that flew out of the epicenter of a cosmic catastrophe billions of years before the birth of Earth. This gold dust flew through the void, mixed with gas clouds, until one day gravity gathered it into the protoplanetary disk from which our solar system was born. Every atom of gold in your jewelry was forged in the fire of a dying neutron star. This changes our attitude toward these monsters. In the last chapter, we called them killers. We said that Magnetars are cleaners, sterilizing the galaxy. This is true. They are destroyers, but they are also creators. Without them, the universe would consist only of hydrogen, helium, and boring garbage. Without them, there would be no heavy elements, no iodine in your thyroid gland, no uranium warming Earth's core, creating the magnetic field that protects us from solar wind. This is the great duality of the cosmos, Shiva, destroyer and creator in one face. The machine that can erase a civilization with one gamma-ray flash is the same machine that gifts that civilization the resources to build microprocessors and spaceships. The death of one star becomes the foundation for the life of another. We are part of this cycle. We are made of stardust, but we are not made only of the peaceful dust of quiet stars. In our blood, in our technology, in our economy, flows the blue blood of the galaxy's most terrifying monsters. But even this is not the limit of the mystery. Gold, platinum, uranium, these are merely byproducts. This is what flew outward. But what happens to what remained inside? What happens in the very center of the collision, where the density exceeds the density of a neutron star, where matter is compressed so tightly that the very concept of matter loses meaning. We have reached the final line. We are standing at the door where known physics ends. Behind this door, space ceases to be just a stage for events. It begins to bend, it begins to break, and perhaps there in this final point of compression, not only space breaks, time breaks there. Let us look into this abyss one last time. So, we have reached the end. We began this journey with a simple atom, 99% empty space. We saw gravity squeeze that emptiness out, turning matter into nuclear pasta, a substance so hard it breaks our very concept of solidity. We saw magnetars, whose fields can erase the memories of civilizations. But at the very heart of this story, one unspoken question remains. A neutron star is an intermediate hell. It is purgatory. It holds on at the last line of resistance. Neutrons brace against each other, screaming at gravity. No, you cannot go further. But what happens when gravity says, I can? Imagine just a little more matter falls onto our neutron star. Just a little gas, or an asteroid, or as we discovered a minute ago, it merges with another star. In that moment, the scales tip. The Tolman-Oppenheimer-Volkoff limit is breached. Nuclear pasta, that strongest material in the universe, breaks with a crunch that shakes the very structure of space-time. The barrier falls. The star, already compressed to the size of a city, begins to shrink further, to the size of a football stadium, to the size of a grapefruit, to the size of an atom, and finally, to a point, to nothing. Matter disappears from our universe, leaving behind only a gravitational scar. A hole, a black hole is born. We are used to fearing black holes as monsters that eat everything in sight. But let us look at it from another side. A black hole is a monument to gravity's victory over everything else, over matter, over light, over energy. But most importantly, it is a victory over time. Albert Einstein taught us that gravity is not just a force that pulls objects down. Gravity is the curvature of space and time. The heavier the object, the slower time flows near it. Even here on Earth, your feet age slightly slower than your head because they are closer to the planet's core. The difference is negligible, nanoseconds over a lifetime. But on the surface of a neutron star, it is no longer nanoseconds. In that region, time runs about 30 to 40% slower than in open space. If you could survive on the surface of a magnetar and looked up at the sky, you would see the universe spinning in fast forward. You would see stars born and dying in a matter of minutes. You would be a time traveler, moving only into the future and moving slowly while the rest of the world rushes ahead. But when a neutron star collapses into a black hole, something final happens. In the center of this collapse, the curvature of space becomes infinite. The wall becomes vertical, and if we believe the equations, in the very depth of this abyss, at the point of singularity, time stops. It does not slow down. It does not stretch. It ceases to exist. There is no yesterday there. There is no tomorrow. There is only an eternal, infinitely compressed now. This scares us more than death. Death is the end of consciousness, but the stopping of time is the end of cause and effect. It is the end of history itself. It turns out that a neutron star is not just the corpse of a star. It is a time machine with the parking brake pulled. It is a border post that reads, "Known physics ends here. Beyond lie dragons." We look at these glowing dots in the sky. We measure their mass. We count their revolutions. We give them names like SGR 180620. We pretend to understand them. But perhaps we are like ants crawling on the screen of a smartphone. The ant sees the light, it feels the warmth, but it has no idea that beneath the glass lies a processor processing information at a speed of billions of operations per second. We see gamma-ray flashes, but we do not see what is happening inside the processor of the universe. Maybe our entire universe is just foam on the surface of something much deeper. Maybe matter is just condensed light, and time is just an illusion created by gravity. We do not know. We have only just started opening our eyes. But one thing we know for sure, the universe is far stranger than we can imagine, and it is far stranger than we are capable of imagining. We stand at the edge of a cliff. Below is darkness, but it is by looking into this darkness that we begin to understand the value of light. I leave you with a final thought. Try to sleep with it tonight. We found out that gravity can crumple steel into vapor. We found out that it can twist space into a knot. But the main question remains, the one to which we have no answer yet. If space can bend so much, can time break completely?